students, and welcome to our online class. I'm Sir Mark and this is the Mathematical Learning. For today's lessons, we're going to discuss the Quarter 2 Module 8, the secants, tangents, segments, and the sectors of a circle. Without further ado, let's start. Of course, let's first talk about the tangent of the circle. You can define where is and what is the tangent of the circle if you know its features. Always remember that tangent of the circle just intersects with the circle at exactly one point. Take this figure as the example.
Take this figure as an example. We can see that the line HE intersects at the circle O at P. The HE is the tangent and the P is the point of tangency. So what is the point of tangency? The point of tangency is the point of intersection of line and the circle.
So encounters two circles with a common tangent. It has a tangent line that is tangent to two circles in the same place. We have four types of common tangents.
First is the common internal tangents. It intersects the segment joining the centers of two circles. Take this figure on our modules as the example, wherein the line X and Y intersects the segment joining the centers of the circle. Hence, we can say that this is a common internal tangent. If there is an internal, there is also an internal tangent. Take this figure as our example, where line P and line R does not intersect with the segment that joining the centers of the circle. With this, we can say that this is a common internal tangent. There is also an internally tangent circles. We can say that the two circles are internally tangent if they intersect in exactly one point and the intersection of their interiors is not empty.
Let's take this figure as an example.
Let's move on to the last type, which is the externally tangent circles. We can say that the two circles are externally tangent if they intersect at exactly one point and the intersection of their interiors is empty. Take this circle as an example, where we can see that the common tangent lies between the two circles, thus the centers of the circles lies on both sides of the common tangent.
Learned about tangents, let's go now to secants. What is a secant? Look at this example. Did you notice something? That's right, you have a good eye. There is a shaded region in the circle. It is called as the sector of the circle. It is a region bounded by an arc of the circle and two radii to the endpoints of the arc.
Let's give this circle some values. The arc PR has a value of 40 degrees, while Q has a value of 8 centimeters. How can you find its value of the sector of the circle? You must use the formula for finding the ratio, where measure of the arc is divided by 360. In this example, we have the value of 40 degrees, meaning in substitution it is 40 divided by 360, which is equal to 1/9. Next is to find the area of the circle using the equation A equals pi r squared. The r in this formula is the length of the radius. By substitution, we have now the value of 64 pi centimeters squared. Now get the product of the ratio and the area of the circle, where sector JKL is equal to 1/9 times 64 pi centimeters squared equals 64 pi over 9 centimeters squared. With computation, we will get an approximately 7.11 centimeters.
I hope that you learned in our lesson for today. Again, I'm Sir Mark and this is the Mathematical Learning. Keep safe. God bless.